Today we're going to create an exponential equation from 2 points, and I'm going to do each method, each problem with 2 different methods, so you can kind of choose which one that you prefer. So the first one I'm going to do is I'm going to take these 2 points, I'm going to turn them into a table, and give you a little bit more of a visual while I'm trying this problem out. Anytime that we want an equation, we want to figure out what the starting point is, so that's why I'm using the table for this strategy. So I'm going to go ahead and fill in up to 6 points since I have the point 6 comma 163.84. I'm going to fill in 2 comma 400. So the first thing I'm trying to look for in an exponential equation is, what is the pattern? Well, because we know it's exponential, we know that it's multiplying. So it's going to multiply to get from the second point to the third point. I don't know what it's going to multiply by. I'm going to call it times n. It's a multiplier. And then it's going to have to do that to get to the fourth point. So I got to the third, I can get to the fourth. I'm going to have to do that same pattern or multiplier to get to the fifth point. I'm going to have to do it again to get to this last 163.84. I feel pretty confident in my algebra skills, so I'm going to go ahead and create an equation off of this right here. So I'm starting at 400. I'm multiplying by m a bunch of times, 4 times. And that's taking me to the end of this, which is 163.84. Now, I bet that most people can at least get started in solving this equation. And to get the m's by themselves, we're going to divide by 400. So I'm going to go ahead and shortcut the m times m times m times m to m to the fourth. And then I'm going to grab a calculator so I can type in this last part, which has a decimal, 163.84 divided by 400. And that gives me 0.4096. At this point, to get m by itself, we can go ahead and take the fourth root on both sides. The fourth root is going to cancel out with the fourth power. When I do that, again, definitely needing a calculator for this one, I get the multiplier to be 0.8. Cool, so I know that the pattern is multiplying by 0.8 each time. I can go ahead and fill in now this table and just double check and make sure that I've gotten to the last point. So 400 times 0.8, I'm using my calculator here again, gets me to 320. 320 times 0.8 gets me to 256. Then 256 times 0.8 gets me to a decimal of 204.8. And if I do that one more time, it does give me 163.84. So I know that the multiplier is correct. Now, in order to go backwards, I want to divide by 0.8. So I just want to do the pattern backwards. I want to divide by 0.8. So 400 divided by 0.8 is 500. And then I'm going to do that one more time and divide by 0.8. I get 625. Why is this important? When you're making an equation, you always need the starting point, the y-intercept. So now that I have that, I can make my equation. My equation is y equals 625 is the start. The pattern, as we came down the pattern, was multiplying by 0.8. That's what we calculated before, so times 0.8. And then when you multiply, that creates an exponent. So here is our exponential equation. 625 times 0.8 to the power of x. And the book is going to do this a little bit differently. And I'm going to go ahead and try their strategy and see if I can end up with the same thing. The book knows that all exponential equations are in the form y equals a times b to the power of x. So all I'm going to do is fill in the information that I'm given. Like, hey, do I have a y value? Yeah, I do. Here's one. 163.84. Do I know the a or starting amount? Nope. Do I know the b, the pattern? Nope. Do I have an x value? Yes, I do. The one that corresponds to this is 6. Now, unfortunately, I cannot solve for two variables unless I have two equations. I'm literally going to do the same exact thing with this. Do I have a y value? Yeah, I'll go ahead and choose the color here too. Do I have a y value? Yeah, 400. I don't know the a. I don't know the b. To the power of x, yep, I have an x value that is 2, so b squared. This is like the elimination strategy that you probably learned in algebra, except for in order to eliminate exponents, which have multiplication, we're going to simply divide these. We're going to go ahead and divide both of these equations. I'm going to go ahead and type in on my calculator 163.84 divided by 400. If that equation sounds familiar, it absolutely should. We did it in the other problem. This gives us 0.4096. A divided by A is 1. Those will cancel out. B to the 6 over B to the second. You got to know some algebra skills. That simplifies to B to the 4. What do we do now? Take the fourth root on both sides. If that sounds familiar, it should. It's exactly what we did in the other one. Our B value was 0.8. That's that multiplier we have over on the side. If you would like to solve for the starting point, you could simply go ahead and take one of these equations and plug in the b as 0.8. So I'll go ahead and use this one right here. 400 equals a times 0.8, and that's squared. I'm going to go ahead and type in 0.8 squared, and I'm going to get 0.64 times a. And now I'm going to go ahead and divide by 0.64 on both sides. Get a by itself. 400 divided by 0.64 is indeed 625. So the same thing that we got in the other problem. For the second problem, I'm going to try both strategies again. I'll go ahead and use the strategy of using the y equals a times b to the power of x. And simply substituting in all the values that I know. So I'm going to try this strategy first. So when I go ahead and use the strategy and I fill in the first points, so my y value that I have is 30. So 30 is equal to. I don't know the initial amount. I don't know the pattern right now. But I do know the x value is 1. And then I'm going to go ahead and do the same exact strategy for the other point. I'm just going to go ahead and do it here. Do I have a y value? Yep, 240. I don't know the initial amount, I don't know the pattern, but I do know that the x value is 4. And I'm doing this one for a reason in this order. And that's because if I try to eliminate these using that big division fraction bar, you're going to see that I'm going to get some decimals on the left side. That's definitely going to give me a decimal. I'm going to get some negative exponents here, which is still possible, but probably not the easiest to work with. So there's a simple thing that you can do. And what that is just write these two equations in a different order. I always like putting the bigger exponent on top. This is just going to help me simplify when I simplify the b values, which is what I'm trying to solve right now. So I'm simply going to take this red equation and I'm just going to bring it down here. I think I can just drag it here, move my fraction bar, and I'm going to go ahead and do the same strategy. So now it's a little bit easier to divide 240 by 30. It's just going to go in 8 times. A divided by A is 1, so those are going to cancel out. And then b to the 4th over b to the 1st is going to simplify to b to the 3rd. So again, this is the reason that I put the bigger exponent up on top, so that I don't get like b to the negative 3rd, or I don't get b's that are in the denominator. So simply putting the bigger exponent on top can make the numbers a little bit easier to work with. At this point, I'm going to go ahead and take the 3rd root on both sides. 3rd root cancels out the 3rd power. And the cube root is pretty easy for this one. That means my b value is 2. At this time, I can go ahead and pick either of these equations to plug in. I'm going to go ahead and pick the one with smaller numbers. I'm going to use 30 equals a times, plug in the b value of 2 to the power 1. All right, that gives me 30 equals a times 2 to the first, which is 2. And when I divide by 2, my a value is 15. How do I put these two answers into an equation? Well, I use the original exponential form that we were given. Y equals, our a value was 15, times our b value is 2, meaning it's doubling each time, and that would be to the power of x. So here is my exponential equation. 15 times 2 to the power of x. I'm going to leave that there. And we're going to go ahead and try it with the other method, which I like to call table method. Why? Because you're just taking these 2 points in the original problem and turning them into a table. So, x, y, 0, 1, 2, 3, 4. Just fill in the points, 1, 30, 4, 240. And this is maybe for your visual learners. So you know that it's exponential, so it's going to have to multiply to get to the second point. It's going to have to multiply to get to the third point. And it's going to have to multiply to get to the fourth point. I'm going to go ahead and create an equation out of what's happening right here. That equation is 30 times m times m times m gets you to an answer of 240. Get the m's by themselves, you divide by 30. Why do I divide by 30? That says times by 30, so I'd like to inverse that or cancel that out. M times m times m, I can shorten that as m to the third. 240 divided by 30, that's 8. Should sound familiar. How do I get rid of the third power? Take the third root. That should sound familiar. Third power, third root, cancel out. The multiplier is equal to 2. Now I can use the multiplier of 2 over in the table. Times 2 gives me 2. A 60. Okay? Times 2 another time gives me 2. 120. And then times 2 another time gets me to 240, so I know I'm correct with the pattern. I'm just going to go ahead and divide 2 backwards, and that will take me to my initial value, my y-intercept, my starting point of 15. So I've got everything I need. All I do is I go to y equals, what is my start? My initial is this 15 here. What is the pattern? We can see that it's times 2, times 2, times 2, times 2. So I put times 2, and then we'll put to the power of x. We know when you multiply over and over and over in a pattern, the shortcut for that is creating an exponent. We can see that our 2 equations are exactly the same. It doesn't matter which strategy that you use.